Please briefly summarize your industry education and professional background.
So I did go to college in Missouri, at the Missouri School of Engineering out there, which was originally the School of Mines and Metallurgy, but is now a regular university. Then I came back to New York and got a master's degree at City College. And then I entered this field. Actually worked for a large, very good consulting engineering firm until I went into business with a couple of other folks, and we started cranking out our own business, etc. So we can give you a little story about some of the work we've done, but I'll let you ask the questions.
Please provide a brief history of the Goldman Copeland engineering firm and what it does.
We started out a very small company, obviously, and then we ultimately kept growing. I was always interested in energy. It's one of my things. And I wound up doing an early solar collector project. Of course, it was thermal, not electricity, in the 1970s on the Lower East Side of Manhattan. And as a matter of fact, my first job, I kind of left in part because they didn't pay attention to energy. But, and then subsequently, just as an idea, we wound up doing a lot of other energy work, including running the largest municipal energy program in the country for New York City. We worked on all the buildings, many of the buildings of New York City. And also over the years, we just kept growing. We're probably close to 70 people now. We have 4 other principals. We do lots of infrastructure jobs, many cultural facilities, the largest real estate companies in the city. We worked for Vornado for almost 4 decades. And all the major cultural folks. We worked on Grand Central for 15 years. I did the Alexander Hamilton Customs House and put the Museum of the American Indian in it. Many other museums. We work for the Morgan Library now and the Guggenheim. You name it, I could go on, but that's kind of where we're at.
So what is the potential for geothermal energy, and why do you believe, from your press release, geothermal heating and cooling can replace all existing HVAC systems in all buildings? And how would that work?
I think they meant to say all types of buildings, not all buildings. Having done a geothermal screening tool for all of New York City, 900,000 lots, and we just completed one for Westchester. It clearly doesn't work everywhere. It depends on the conditions, and it's perhaps the more important issue is it cost effective everywhere. You can get it to work marginally, but perhaps that's not cost effective. So that statement is maybe could be a little clearer. It doesn't work everywhere economically, perhaps. And it certainly doesn't work for a 50-story building sitting on a little tiny piece of land. But all types of buildings, a small office building with a large parking lot that could take underground geothermal is feasible, for example. But so it needs to have some clarity, which I won't go into unless you ask, because there's a lot of other buildings that we've looked at that have had challenges that were designed inappropriately. So we do believe, by the way, in using a hybrid system, because not all local soils can absorb that much heat from cooling, for example. So we prefer sometimes to use a cooling tower to vent the extra heat.
Our readers are mostly engineers, so you can get technical, but can you give me a brief kind of description summary of how geothermal would work in a heating and cooling system, HVAC?
as you probably know, we are all trying to move, especially in the New York area, and I'm sure out in California, maybe Colorado, we're all trying to move away from using fossil fuels. At this point, a lot of our electricity is still produced by fossil fuels. So we have quite a ways to go. And even in New York State, we recently got rid of the last at least local nuclear power plant. We are trying to move down the road and ultimately hoping that all of our electricity could be produced by wind or solar. And so we are encouraging, New York State is encouraging folks to move down the path of using more electricity. So as we use electricity, one of the ways we can do heating and cooling is through what's called a heat pump, where we either reject or absorb heat from let's say the air, which works less and less efficiently as the air gets hotter and hotter or colder and colder, right? So the advantage of a geothermal system is the ground temperature is typically in the 50-degree range, depending on your location. And as long as you don't particularly overload it with too much heat, which of course we've seen in some cases, or absorb it, you can use that underground surface to either reject heat or absorb heat. And you're doing it at a constant temperature of in the 50-degree, 50, 60, 30, 40, whatever, but you're not doing it at 95 or 100 degrees and 10 degrees or whatever. So that's the advantage of using geothermal. And using a heat pump, you're essentially absorbing some of the heat from the ground efficiently and using it to heat or cool your building.
How about a short summary of how the building is connected to the ground, and how is the heat transferred and moved around?
So once the heat pump either rejects or absorbs heat, it is going to go in a pipe, and the pipe can either be warm fluid, and probably use the same set of pipes. It could be refrigerant is another option, which you normally use with a heat pump, and that warm liquid or cold liquid, whatever, can now heat or cool the building. So that's the idea. And you use fan coil units or little air handlers or something like that to do it.
Can you describe what is the New York City geothermal screening tool, and how does it work? And how is it different from the Westchester version, both similar and different, that just recently came out?
The New York City tool is a very detailed tool that looks at different types of structures. It's quite detailed. We worked on it quite a while. So, for example, there in New York City, believe it or not, well, other parts of the country as well, there could be 15 different types of structures, from a simple warehouse to a sophisticated office building to a residential tower to a single residence, all kinds of, to a museum. So there's all kinds of different structures. And the tool for New York actually is quite sophisticated and allows you to actually put in a structure and quite detailed into the tool, along with all of the area. And it's also uses pretty sophisticated USGS underground maps, geological survey maps, that tell you what's below the ground, how much rock, how much soil, is there an aquifer there that can't be touched. So the New York City tool is very, very sophisticated. From what I can tell, and I have to check with my staff a little bit, but the Westchester tool is a little more oriented towards residential buildings. It may have other types of buildings. I'm sure it does. I haven't used it. It's just coming out officially tomorrow. But you know, I have put some structures in there, and I'm not aware that the geological efforts was as sophisticated as they were in New York. But you know, I need to find out a little more about that. But that's my understanding.
How should civil and structural engineers be looking at geothermal energy in their plans and designs?
I think they should be looking at it in every case. I mean, there'll be issues with some sites where the amount of ground area is exceedingly limited, and that would, like, more or less cause folks to walk away from it. But if there are you know, locations where you have a reasonably good ground surface area, you know, my lady's father lives in Michigan, and he lives on a farm, and all he had to do is run some little plastic piping out on his an acre of his farm, and he's got a beautiful heat pump system that works summer and winter. So you have to look at each and every instance. And even if you're a little limited on area, I wouldn't give up on it, because maybe there's, especially in cases where there's a more concentration in the building of cooling load that has to be rejected, putting in an electric, you know, operated cooling tower that rejects the heat to the atmosphere can be a way of complementing geothermal. So we would strongly encourage everybody to look at it in every case. In no matter what you're looking at, we clearly have to be looking at the future and climate crisis as opposed to climate change. And so we should always be looking at other ways to do this, and whatever we can do to diminish the use of fossil fuels is something we ought to work on.